We've had some cost overruns in Europe, 1 or 2 cases, whereas China is building in 3 years, 4 years. China is the lead in terms, numerically speaking, in terms of the increase. China has more than 50 reactors in operation, and at the moment, as we speak, is building more than 20. China will take over, perhaps as the second and perhaps as the first, because they have very ambitious plans.
China National Nuclear Corporation, CNNC, has recently launched a heat-led nuclear project in Jiangsu, marking a significant milestone in the country's pursuit of clean and efficient energy solutions. This project is not just another addition to China's growing nuclear energy portfolio, but a pioneering step toward integrating nuclear power into district heating systems, a move that could revolutionize how urban areas manage their energy needs. The initiative underscores China's commitment to reducing carbon emissions while addressing the growing demand for sustainable heating solutions, particularly in densely populated regions. The implications of this project extend beyond national borders, drawing attention from global energy stakeholders, policymakers, and environmentalists who are keenly observing its progress and potential scalability. The heat-led nuclear project in Jiangsu leverages the inherent advantages of nuclear energy to provide a stable, low-carbon heat source for residential and industrial use. Unlike traditional coal-based heating systems, which contribute significantly to air pollution and greenhouse gas emissions, nuclear-powered heating offers a cleaner alternative. The technology involves extracting heat generated during nuclear fission and channeling it through a network of pipes to supply warm water for space heating and other domestic applications. This method is not only environmentally friendly, but also highly efficient, as it utilizes excess heat that would otherwise be wasted in conventional nuclear power plants solely focused on electricity generation. By repurposing this heat, the project maximizes the utility of nuclear reactors, making them dual-purpose facilities that cater to both power and heating needs. One of the most compelling aspects of this project is its potential to address China's pressing air quality issues. Northern China, in particular, has long struggled with severe winter smog caused by the widespread burning of coal for heating. The transition to nuclear-based heating could drastically reduce the reliance on fossil fuels, leading to cleaner air and improved public health outcomes. Moreover, the project aligns with China's broader climate goals, including its pledge to achieve carbon neutrality by 2060. By demonstrating the viability of nuclear heating, Jiangsu could serve as a model for other provinces and cities looking to decarbonize their heating systems. The scalability of this technology is another key advantage, as it can be adapted to different urban and industrial contexts, potentially transforming the energy landscape across the country. The economic benefits of the heat-led nuclear project are equally noteworthy. Nuclear energy, despite its high upfront costs, offers long-term cost stability compared to fossil fuels, which are subject to price volatility. By integrating heating capabilities into nuclear plants, the project enhances the economic viability of these facilities, making them more attractive investments. Additionally, the construction and operation of these plants create high-skilled jobs, contributing to local economic development. The Jiangsu project is expected to stimulate innovation in nuclear technology, fostering a new generation of reactors designed specifically for combined heat and power applications. This could position China as a leader in advanced nuclear solutions, opening up export opportunities for its technology in markets seeking sustainable energy alternatives. Internationally, the launch of this project has elicited a range of reactions. Countries with advanced nuclear programs, such as France and Russia, have expressed interest in China's approach, seeing it as a potential avenue for collaboration. France, which derives a significant portion of its electricity from nuclear power, is particularly keen on exploring how similar systems could be implemented in its own urban heating networks. Russia, with its expertise in nuclear technology and cold climate challenges, views the project as a proof of concept for its northern regions. Meanwhile, nations transitioning away from coal, such as Poland and Germany, are closely monitoring the project's outcomes as they seek viable alternatives for their heating sectors. The international community's interest underscores the global relevance of China's innovation in nuclear heating. However, the project has also faced skepticism, particularly from countries with strong anti-nuclear sentiments. Germany, for instance, which is phasing out nuclear power entirely, remains cautious about embracing nuclear-based heating solutions. Concerns about safety, radioactive waste, and the potential for accidents continue to shape public opinion in many parts of the world. China's ability to address these concerns through robust safety measures and transparent communication will be critical in gaining broader acceptance for its nuclear heating technology. The Jiangsu project will serve as a litmus test, demonstrating whether nuclear heating can be implemented safely and efficiently on a large scale. Success in this endeavor could pave the way for greater international adoption, while failure could reinforce existing reservations about nuclear energy. The environmental impact of the heat-led nuclear project is another area of global interest. As the world grapples with the urgent need to reduce carbon emissions, nuclear energy is increasingly being recognized as a vital component of the clean energy transition. Unlike renewable sources like wind and solar, nuclear power provides a consistent and reliable energy supply, making it an ideal complement to intermittent renewables. By extending the use of nuclear energy to heating, China is further leveraging its low-carbon benefits, potentially displacing millions of tons of CO2 emissions annually. This aligns with global climate targets and could inspire other nations to explore similar integrations of nuclear technology into their energy systems. The project's environmental credentials are likely to enhance China's standing in international climate forums, where it has been actively promoting its green initiatives. From a technological standpoint, the Jiangsu project represents a significant advancement in nuclear engineering. Traditional nuclear plants are optimized for electricity generation, with little consideration for heat utilization. The heat-led approach requires innovative reactor designs and heat exchange systems to efficiently transfer thermal energy to district heating networks. CNNC's efforts in this domain could lead to breakthroughs in small modular reactors, SMRs, which are increasingly seen as the future of nuclear energy due to their flexibility and scalability. SMRs could be deployed in urban areas without the space constraints of large reactors, making them ideal for heating applications. The knowledge gained from the Jiangsu project could accelerate the development of SMRs worldwide, ushering in a new era of nuclear technology tailored to diverse energy needs. The social implications of the project are also worth considering. Access to reliable and affordable heating is a critical quality of life issue, especially in regions with harsh winters. By providing a clean and stable heat source, the project could improve living standards for millions of people. It also has the potential to reduce energy poverty, a pressing issue in many developing countries where heating costs can be prohibitively high. The success of the Jiangsu project could inspire similar initiatives in other parts of the world, particularly in countries with cold climates and growing energy demands. This social dimension adds another layer of significance to China's nuclear heating venture, highlighting its potential to address both environmental and human welfare challenges. In conclusion, CNNC's heat-led nuclear project in Jiangsu is a groundbreaking initiative with far-reaching implications for China and the world. By integrating nuclear energy into district heating systems, the project offers a sustainable solution to the dual challenges of carbon emissions and air pollution. Its economic, environmental, and social benefits make it a compelling model for other regions seeking to transition away from fossil fuels. The international community's mixed reactions reflect both the promise and the perceived risks of nuclear technology, underscoring the need for careful implementation and robust safety protocols. As the project progresses, it will serve as a critical case study in the feasibility of nuclear heating, potentially shaping the future of global energy systems. Whether viewed through the lens of climate action, technological innovation, or social equity, the Jiangsu project represents a bold step forward in the quest for a cleaner, more sustainable energy future. The world will be watching closely as China navigates the complexities of this pioneering endeavor, with the hope that its successes can be replicated and its lessons learned applied universally.